Kia ora, good evening. Welcome to one more session of Coding Night New Zealand. And tonight we have a special guest, Will Velida. How are you?
I'm good, man. That countdown gets me every time. I remember it last time because you were very kind enough to have me last year. Um, and yeah, that countdown music is epic because it's the BBC countdown music. So it gets me in that mood. Sorry, I thought I'd just start off with that. It's incredible.
I saw you laughing, so no need to explain.
Oh, it's great. I love it.
Nice. Yeah, welcome back. So we had like Will last year and talk about Microsoft Orleans. So this time around, he's bringing like Azure Container Apps with GitHub Actions. Can you just give some highlights on what you're gonna bring?
Yeah, so Azure Container Apps, I'll talk a little bit about the lifecycle management of container apps, which opens up some really cool deployment strategies that we can implement when deploying container apps. So in today's session or tonight's session, depending on where you are in the world, we're going to be talking a little bit about container apps for those of you who aren't too familiar with container apps. And then we'll dive into some demos, specifically blue-green deployments and A/B testing to show how we can actually manage revisions in container apps, assign traffic to different revisions, and how we can actually use that within GitHub Actions workflow files to automate the deployment of our container apps using these strategies.
Oh, nice. Yeah, really excited for that. One of those hot topics, as usual. You always bring like those. But before we start, let me just bring this to the community. So, just to explain a little bit so of what we are doing here on the community. But we are a community of developers. So we're gonna see on the sessions that we had like in the past, we'll talk about like development tracks and technologies. So we are a community group of developers. We love coding and to follow best practices on software development languages and technologies. We in general like are more focused on Microsoft stack, but we are open to discuss like other technologies as well. But the main intent is to enable developers with practical knowledge so you can launch your careers. And if you are like a junior to a lead dev, you're gonna find like some really good content in our user group. I would like also to highlight that we are part of AzureTar.com. So it's a cloud native group where we talk about the latest and greatest about like what's happening on the cloud native space. Also part of .NET Foundation, so where we explore the different projects available and funded by the .NET Foundation group. With that, no further ado, I would like just to give you the floor, Will, if you could just bring your slides.
Awesome. Oh, let me share it again. And while I'm figuring out how to use StreamYard, even though I've used it for a couple of years now, yeah, just want to congratulate you, Marcel, on becoming an MVP.
Oh, thank you.
Welcome to the club. Well, I used to be a part of it. Now I'm not because I'm working for Microsoft. But yeah, huge congratulations and huge thank you to everything that you do for the community. It's about time you got recognized, and just wanted to use this very public forum to congratulate you because this is actually the first time we've talked this year. So
Oh,
congrats,
thank
man.
you. Yeah, appreciate that. And that's the work that we like just to share with the community. I think that recognition, I'm very thankful for that. Just a privilege, really, just to be part of the program. Yeah. Thank you just for saying like your kind words.
Well, you
Yeah,
deserve it, man.
cool. Thank you. The floor is yours, man.
Awesome. Cool. Okay. So, like I mentioned earlier, I first introduced myself. So, my name is Will Velida. I'm a customer engineer working in the Fast Track for Azure team, helping engineers like yourselves to build robust applications in Azure. My primary focus is on cloud native technologies. So, I help customers with app development and modernization, providing architectural guidance, doing deep dives on technologies such as serverless and containers, and helping them to basically build awesome applications. So in today's session, we're going to start with a little bit of an introduction to Azure Container Apps. It's a fairly new technology. It's been GA for just almost a year now. And we'll talk a little bit about what kind of applications we can build with Azure Container Apps as well. Then we'll dive into the concepts a little bit before going into two demos. So we're going to be demonstrating one blue-green deployment scenario and another A/B testing scenario. And we're going to do all of this inside GitHub Actions workflow files. Once that's done, we will have a bit of a Q&A session at the end. So if you have a question, feel free to post a comment wherever you're watching, and we'll address questions at the end. Cool. So what are container apps? So essentially, container apps was born out of a necessity, well, out of a realization that Kubernetes is hard. When I'm interacting with customers, we are constantly citing Kubernetes and the complexity around Kubernetes as a blocker from adopting containers and microservices application patterns. Now, Container Apps is built on a foundation of several open source technologies that help deliver the same microservice benefits as Kubernetes. But essentially, it's Kubernetes, but we manage it for you. So behind the scenes, every container app runs on Kubernetes, and it has open source integration with open source technologies such as Kubernetes event-driven auto-scaling, distributed application runtime, or Dapper, and Envoy, or these are all integrated within the hosting services. However, the difference to Azure Kubernetes Service is that you're not exposed to the underlying Kubernetes infrastructure. So when you're operating container apps, it's not like you can run kube control commands to operate your cluster. There's no need for that. That responsibility is handed over to Microsoft, and your focus is really on building those microservices and applications, helping you to kind of leverage the benefits of Kubernetes without having to worry about managing Kubernetes itself.
Will, I think your screen just disappeared.
Did it? All
Your
right, let
sharing.
me,
Yeah.
this could be fun. So for those of you who aren't based in Auckland, I've just reshared my screen. Can you see? Awesome. We're going through a bit of a storm or a cyclone, better way of putting it. So Marcel's power might go, my power might go. We are completely we are free winging it tonight. So it's going to be very entertaining. So hopefully I don't get cut off mid-sentence. That would be quite funny. Anyway, so let me get back to this. So like I said, Container Apps is built on great open source technologies. So it runs on top of Azure Kubernetes Service. It's integrating with Kada for its scaling capabilities. You can use best practice application frameworks like Dapper, and it also uses Envoy for service discovery. And with this, you can take advantage of these platforms. Hang on. So this actually gives us the advantage as application developers to perform application lifecycle tasks such as upgrading applications, shifting traffic between different revisions, and versioning in a much simpler way than we would have to, say, if we were operating a Kubernetes cluster. Because you're not burdened by the underlying orchestrator, we've essentially shifted our focus to building our applications. So with Container Apps, you can build microservices, APIs, event processing workers, and background jobs using, as long as you can containerize them, and using any programming language or framework that you like. If you're coming from an Azure Functions background, I'd like to say that Container Apps gives us a little bit more flexibility because there's no enforcement of a programming model. With Azure Functions, it's great for integrating with other Azure services, and it's good for that integration piece. However, there is that programming model that it kind of enforces on you when you're developing your functions. So containers or Container Apps provides us a little bit more flexibility when it comes to that. However, if you're currently working with containers, specifically Windows containers, currently these aren't available on on Container Apps. It's limited to Linux workloads. I'm not sure if or when Windows containers will ever be available on container apps. I know it is an ask, but currently, as of the time of recording, you can't develop Windows containers on container apps.
Just another thing, your screen just disappear again.
Uh, let me.
Bringing full screen, maybe it
There,
remains.
how about that?
Nice.
Awesome, cool. Apologies, everyone. We're having an interesting night. Um, And with container apps, we can actually scale dynamically based on events leveraging CADA. So it provides built-in HTTP-based auto scaling. So essentially, with container apps, we can scale to 0. And we can also do this with event-driven auto scaling. So we might run our containers that process messages from queues, databases, whatever. And this is based on Kubernetes event-driven auto scaling. There's a whole growing list of CADA supported scale triggers. So you can use Azure Event Hubs, Apache Kafka, RabbitMQ, MongoDB, MySQL, etc. And the idea here is you can actually scale to 0 and pay for only what you use by the second. So what can we build with Azure Container Apps? A whole variety of different applications. So some common ones that we see customers really and engineers use Azure Container Apps for, deploying API endpoints. So we might have an API app with HTTP requests, and one scenario that we will do with a web app, not an API, but for any kind of application that's accepting HTTP traffic, we can split HTTP traffic between several revisions of an application. We might be developing container apps to host some background processing applications. So we might be transforming some data in a database somewhere, and we can use container apps to run that process for us. One thing that I do see developers do is use Azure Functions to try and do this, and it's not really what Azure Functions is used for. There are some workarounds depending on how you host your Azure Functions that can kind of do it, but it's not really designed for that. So Container Apps is probably a little bit more of a suitable platform to run those kind of background processes. Handling event-driven processing. So like I mentioned earlier, we might have a container app that's reading messages from a queue and processing those messages as they arrive. And we can actually use, say, Azure Service Bus or Storage Queue scalers, CADA supported scalers to scale our application to process those messages. And running microservices. So Container Apps is really designed for that kind of microservices architecture to try and simplify the hosting of that. And you also have the option to integrate with the Dapper framework as well, which is pretty cool. Now, one of the big questions that we do get asked by customers is, okay, so Container Apps is a simplified version of Kubernetes service. When should I use container apps and when should I use Kubernetes? Now, the main focus point here is really flexibility versus productivity. So if you're using Kubernetes today and you're happy with the service, you don't really want to change or stop using Azure Kubernetes service, this talk is no way attempting to sway those who love and use Azure Kubernetes Service today to move them to container apps. The value proposition hit for container apps is that if you're wanting to work with containers, but you don't want to have to deal with managing the underlying infrastructure, or you don't have the time to invest in learning Kubernetes because Kubernetes is a very complex system, container apps is a great option. Cool, so that's kind of like the high level overview of container apps. So now we're going to dive a little bit deeper into some of the concepts. So individual container apps are deployed to a single container apps environment. And this acts as the secure boundary around groups of container apps. Container apps that are deployed to the same environment share the same virtual network, and they also write logs to the same log analytics workspace. When you provision a container app environment, essentially a virtual network which acts as that boundary around the environment is deployed alongside it. And if you decide to just deploy a container app environment without a VNet, essentially that VNet is still provisioned, but it lives in Microsoft's tenant. So you don't manage that, we manage that VNet for you. You can deploy a container apps environment by providing an existing or your custom virtual network that lives in your subscription when you create the environment. So if you want control over the virtual network resources, we recommend that you deploy your container app environment with your virtual network. Now, within the environment is the container apps themselves. So a single container app will host a single service that includes the desired state configuration. And like I mentioned before, it's a single independent microservice that gets deployed within your container app environment. And Azure Container Apps itself will manage the details of Kubernetes and container orchestration for you. Now, containers in container apps can use any runtime, programming language, or development stack of your choice. And as I mentioned earlier, they support any Linux-based container image. So if you have Linux workloads, you can deploy them to Azure Container Apps. There's no support for Windows containers as of this recording. Containers, you can actually pull container images from public and private container registries. So if you're using a private container registry, such as Azure Container Registry, you can actually configure your container app to pull images from that container registry into your container app. And you can use managed identities to actually pull those containers as well, providing a little bit more security, which is great. However, container apps can't run privileged containers or processes that require root access. So if you want to run privileged containers, you can't do that in Azure Container Apps. You could also define multiple containers to run together in container apps that are co-located and scaled together. This isn't to say that you can run multiple microservices within a single container app. This is more for providing support for sidecar containers alongside your core workload container. So if you're if you want to run containers together, you might again have that sidecar to support your main workload, and then you can share the scale rules among containers. You can group multiple containers that need to be co-located on the same infrastructure, and you might have direct communication amongst containers on the same host. It is a pretty advanced use case, and we generally advise engineers not to follow that pattern, but the option is there if you need to and want to do that. Cool, so now we're going to get into some of the bread and butter of what we're going to be talking about tonight. So container apps has this concept of revisions. So if you're coming from an app service world, you may be fairly familiar with deployment slots. Revisions are a similar kind of concept. Revisions are essentially immutable snapshots of your container app. And container apps can either run in a single revision mode, which is the default, or multiple revision mode. So single revision mode essentially means there is only one revision of your container app that will be active at any time within your container app. So when you're deploying new revisions to your container app, and we'll talk a little bit about how revisions are triggered from changes, that revision will only ever be active in your container app. Whereas multiple revisions, or multiple revision mode, sorry, is where we can run multiple revisions of our application side by side. So in this kind of diagram here, I've got two revisions running kind of side by side, running in my container app. Side by side is not the right way of putting it. And here we might be splitting traffic between those two revisions. So we might be splitting the traffic 50-50. We might be splitting 80% to one revision and 20% to the other revision. And so with multiple revisions, we can run multiple revisions concurrently at the same time. And this is most useful for when you enable ingress to make your container app accessible via HTTP. So we see revisions being used when we want to direct traffic from one snapshot to our container app to the next. And some typical strategies that this is kind of helpful for are those A/B testing and blue-green scenarios. So just a few concepts about revisions. So when you deploy your container app, essentially a first revision is automatically created for you. It's not something you have to explicitly create. Um, when you're changing the template of your container apps configuration, um, essentially new revisions are automatically created. So this will be changes to stuff like the container image itself, any environment variables, CPU, memory allocations. Those will trigger new revisions. Now, revisions are immutable, but they are affected by global configuration values, so which will apply to all of your revisions. So these are things like secrets and DAPA settings. So just to kind of illustrate that idea a little bit more, so a revision scope change is a change to the template of our container app. So this includes revision suffix changes, container configuration and image changes, and scale rules. While application scope changes are changes to the configuration of the container app itself. So this is the secrets that we use. What revision mode, because you can change between single and multiple revision mode. The ingress that we configure for our particular container, the DAPA settings that are applied to our container apps, and the credentials that we use for private container registries. And then just to recap on revision mode, so single revision is essentially only one revision is active at any time. And when you deploy new versions of your container app, that will replace the current active version, and that will become the active revision itself. A little bit about how that kind of affects downtime. So container apps provides the advantage of zero downtime deployments. So when you're deploying a new revision, essentially what happens is behind the scenes health probes are kind of run in the background to check if your latest of the revision that you're about to deploy is active and it's willing to accept traffic. Once it passes those health probe checks, that becomes the active revision and traffic is allocated to that latest revision. In multiple revision mode, here we can run multiple revisions of our application simultaneously. We can use revision labels to direct traffic from specific revisions, and essentially revisions will remain active until we deactivate them. So you might have many revisions in an active state, but no traffic being allocated to them. By default, container apps stores up to 100 revisions at any time, because essentially it's 100% of traffic. So you have the ability to kind of allocate 1% traffic to 100 revisions if you want. Not a common use case. It's just how it's stored. Once you go over that 100 revision limit, your oldest revisions start to get purged from your container app. Awesome. A little bit about replicas as well. We won't touch too much of this in the demo, but I think it's worth calling out. So the unit of scale in Azure Container Apps is called a replica. So when we're running it in multiple revision mode, it's important to keep in mind that each revision can have its own scale rules. So if you're working with multiple revisions, you could have Container App 1, Revision 1 running with 10 instances. And then you might deploy a new revision and say, okay, the max replicas for my container app now is 5. So the second revision might have 5 replicas running based on its own scale criteria. So the call out here for replicas is really keep in mind that they are tied to specific revisions. So if you're changing replica rules, you're testing different scaling, just keep in mind that the maximum that the scale rules are applied to a revision, not a container app at all, not at the container app level. Awesome. So now we're going to go through two demos. So we're going to go through a blue-green deployment scenario first, and then we're going to go through an A/B testing scenario. So what I'm going to do is just get out my slides and go straight into the portal. Cool. So what I've got here is a very simple resource group with two container apps, log analytics workspace. There's my container app environment, and there is my container registry. And for our blue-green deployment scenario, I'm going to go into this Web API container app to start with. Now, if I navigate to this container app is accepting ingress, so it is open to public traffic. This is purely for the purposes of this demo. So if I click on this, that's going to take me to this default kind of base image that comes with container apps. But what I've got, if I open up my API, is a very simple API project that's essentially going to return back an immutable of weather forecast. So let me just scroll in a little bit. So yeah, we're not really doing anything special here. It's the basic standard API project that's just going to return some weather information. So what I need to do, I'll go into kind of my blue case, into Visual Studio Code. And we're just going to run through this YAML file. So here I've got several jobs defined within my GitHub Actions workflow. And first up, we're going to build our API project. So essentially going to go into that Weather API project, install our dependencies and essentially build it, make sure it's all good. I haven't got any unit tests configured for this API project, but here's when you run some unit tests to make sure it would build. There's nothing specific here to container apps, but when you're deploying containers to container apps, you might be working within a microservices architecture, so you might be doing some infrastructure deployment at the same time. That's not what's happening here, but one recommendation that I would make, if you are deploying application and infrastructure code side by side within the same workflow file, to make sure that you kind of have your artifact and to make sure that your project is going to pass all the tests and it's going to compile properly. Make sure you build your API projects or your application code project first before you deploy your infrastructure code. This is I've seen a couple of scenarios where people have deployed infrastructure before focusing on their application build and testing, and they've spent a lot of time waiting for infrastructure to be provisioned, which is not an efficient use of time. Cool. So then once I've made sure that my project is built, essentially we're going to build our container image. So notice that I'm running all of these on Linux GitHub runners. You do have the choice of Windows runners and Linux runners, and I'm using GitHub hosted runners. Not you can, if you're coming from a Azure DevOps background, you can run self-hosted runners as well. But here I've added a needs property here for the build API project. So that's going to take a dependency on this build API project. So provided this job has succeeded, we're then going to build our container image. So here I'm just going to log in to Azure through the CLI, so I can get my the name of my Azure Container Registry. So if I bring up my bicep file, I've got a very basic container registry that I'm going to be pushing my images to. So yeah, once I get the credentials there, I'm going to build and push my API image to Azure Container Registry. And that's just going to use some simple Docker commands here. You can use AZACR commands to do this as well, but I'm just using Docker for this one. It's just a preference. Cool. So once I've built my container image, we now get to deploying to a blue slot. So essentially, I'm doing all the same things here, but what I want to do is I want to get this current revision. So if I just get some more real estate so that appears on the screen. So here I'm running an AZ, actually no, that's not going to be good. I'm running an AZ Container App command to get the specific revision that's deployed to my container app here. So here, there's a whole bunch of Azure CLI commands that you can use to interact with container apps. So in this one, I'm listing revisions. So I'm pointing to my container app, and then I'm running this query that's essentially going to get these properties, so the revision name, replicas, etc. And I want it to return this revision property. So I'm going to get the latest revision property by running that query. And once I've gotten that revision, I'm going to set it to a variable that my GitHub workflow action can use. Once I've done that, I'm going to deploy to the blue slot. So here I'm going to make a copy of my current revision. So using the AZ CLI, you can actually make a copy of your current revision. I'm going to pass in the image that we've just built. And then once I've made that copy, I'm going to set the ingress traffic to my current revision to 100. So essentially, that current revision is still going to get 100% of the traffic. But I've created a copy of that current revision using the new image that I've built. So essentially, what that copy has done is created a blue slot for us to run some tests. Once I've created that blue slot, I'm running I'm running the same revision list command, but this time I'm getting the fully qualified domain name of that revision. And once I've done that, I'm going to set that to a variable as well. Because this variable, I've then got some integration tests. So if I go back into my web API project, it's a very basic integration test, which essentially says, make sure that when you call this endpoint, it returns a 200. Not the most sophisticated integration test, but essentially this environment variable blue slot URLi .NET test has the ability to pass environment variables through. So I've gotten my blue slot URL, and now I'm passing that URL along with the endpoint to call my API as an environment variable to run that test. Once I've done that, and provided the test has passed, we're going to then promote that to our green slot. So here I've got, I'm going to log into Azure, going to get the login server for my registry so I can pull my image. I'm going to get the blue slot, and then I'm going to promote the blue slot to the green slot. So essentially the important line here, this AZ container app command, we're going to set the traffic to that slot to 100%. So it's a little different with in an Azure App Service world, you might have deployment slots specifically. So you can actually do that nice kind of auto swap between different deployment slots. Here, because revisions are immutable, essentially that blue slot isn't switched over. We're not switching over the blue to the green. We're essentially allocating 100% traffic to that particular slot. Cool. So to kind of see this in action, if I go into the Azure portal, I will go into revision management. And here we've actually kind of got this, I've deployed this ahead of time. So if I go into my GitHub Action workflow file, not this one, into GitHub Actions, I can see that I've got a review ready for me to review and deploy to production. So one of the things that I should call out here in my promote to green job, I've added an environment parameter here called production. And GitHub has this ability, if I go into settings, you have this ability to configure environments with protection rules, variables, and secrets. And I've defined an environment called production that has a protection rule that I have to explicitly approve this for anything to be deployed to that environment. It's almost, it's not quite parity with Azure DevOps. Azure DevOps, you can do this. You can kind of call external webhooks as well. There's a lot of cool stuff you can do with environments. But for this, for the purposes of this demo, all we're doing is just adding, all I've done is just added myself as a required reviewer. So if I go back into Actions, and if I look at this workflow run for blue-green deployments, if I go into this deploy to blue step, let me zoom in a little bit here, I'll look at my test, I can see that this blue slot URL has been extracted. So if I go into the Web API, there's no traffic being directed to this slot. But if I open this up, you can see that every revision will have a specific URL. So if I just copy and paste that and just write weather forecast, hopefully I should see the JSON being returned back to me. So no traffic is being directed to this particular revision, but it is a callable endpoint that we can use. So essentially, because it's accepting ingress from the public internet, we can make a call out to this. So our test is essentially calling this revision URL and performing our tests against this. So now that we know that our tests have passed, essentially we can approve this deployment. And this will start the process of promoting that blue slot or that blue revision to green. So essentially what this command is doing is we're now going to allocate 100% of that traffic to that slot. So at the moment, if I just get out of that, 100% of traffic is going here. So if I click on this and just go straight to that revision URL, it's giving me that base image command. And this is the main URL for this container app. So it's just giving me that, the base image. So once this deployment has been completed, we should see instead, just append this now, it's not quite ready yet, we should see this JSON response being returned because it's now accepting 100% of our traffic. If I go back into GitHub Actions, that's going to run. That might take a couple of minutes. So just having a look at the questions, I can see the comments now. I figured this out on on StreamYard. So
yeah, we have like few questions in here. Not sure if we can take like just now, but like one, I'm just bringing one from Shirin Patel. Like, what's best for event-driven programming, Azure Function or Container App?
This is my favorite senior engineer answer. I'm not senior, I'm an intermediate customer engineer, but this is my favorite answer that all the senior engineers at my previous jobs used to give me. It depends. So one of the things I love about Azure Functions is its simplicity. It's really simple to integrate with other services. So Service Bus, Cosmos DB, there are built-in triggers for that come with the programming model. So if you're looking for kind of like a simplified programming model where you don't have to do too much of the heavy lifting, Azure Functions is great. Container Apps is awesome because it gives you a lot more flexibility. But when it comes to scaling, particularly scaling on events using Kada, that is super simple. So using Kada within Kubernetes, you have to install it on the cluster. There's a little bit of configuration. Kada already comes with Azure Container Apps. So all it really is defining the scaling rules. It's basically 5 lines of code in Bicep. The only tricky part is trying to convert Kada scalar YAML formatting to Bicep templates or Terraform, not Terraform templates. It's not. In Container Apps for Terraform, the Azure RM provider has come out, but it hasn't got support for scaling yet. So I'm keeping my eye out for that. So yeah, it's a bit of a it depends answer. it really depends on what your needs are. They're both great, but they do have drawbacks with
Cool.
flexibility.
I noticed like the provision has finalized. Not sure if you want to
Yes,
grab more questions or jump back to the code.
I'll jump back in
Yep.
because if I refresh that, we should see now that 100% of our traffic has now been allocated to our latest revision. So essentially, our blue slot has now been promoted into our green slot. So this is what was being returned earlier. So if I now hit this endpoint with a forecast attached, there's my JSON response.
Cool.
Cool. So there, it's a very basic blue-green deployment scenario. But just to recap, we've essentially built our container image, we've deployed it to Azure Container Registry, and then we've deployed it to a blue slot. So we've made essentially a copy of a revision, passing in the image that we've just built. So we're thereby creating a blue slot for our new container image, and we've set traffic to our current revision to 100%. So ensuring that our new revision doesn't get allocated any traffic and that the revision that we're currently using is still using 100%. Then once we've done that, we retrieve the blue slot URL, getting this by using this AZ Container App revision list command, and then running our integration tests against that blue slot URL. Once our tests are passed, we've then promoted it to our green slot and getting 100 by allocating 100% of our traffic to that blue slot. Awesome. So that's kind of green deployments. That's our blue-green deployment scenarios. So now we're going to move on to A/B testing. So for A/B testing, essentially what this is you might have two versions of your application, but as you're deploying new versions of your application, you might want to allocate a certain percentage of traffic to that version of your application to do some kind of like in production testing. So you say you're developing new features and you want to test them out with just a subset of your customers. This is what you would use A/B testing for. So if I go back into the Azure portal, here I've got a different application. And this is just basically a simple UI. That's a very bog standard ASP.NET Core standard template. And this is essentially our main application, for a lack of a better term. So if I go into Visual Studio, essentially all I've done is added this new line. If you want to see the weather, look outside. So always the best weather forecast available to us. And essentially this is going to be the new version of our application. So if I go into my YAML file, it's very similar in the way that we build and push our container to Azure Container Registry. So essentially, I'm just going to be building my web project and then deploying the container. In this deploy to app job, we've got some different steps that we're performing. So once we've gotten our Azure Container Registry, I want to get the last revision name for my web front-end application. And then once I've done that, essentially, when we are deploying our container app, we are again creating a new copy of our revision. So again, we're passing in our front-end image that we built within this pipeline. And then we are setting the traffic between different revisions. So as I mentioned earlier, if you're running your container app in multiple revision mode, you can allocate a direct traffic between those two revisions. So here, what we're going to be doing is we're going to be splitting our traffic 50-50. In A/B testing scenarios, you might want to play with this kind of direction of traffic to suit your needs. It probably wouldn't be 50-50. You would want to be a little bit more um, selective and how you expose your different revisions of your container app. But it's just essentially so we can actually see the new revision of our container app a lot faster. So what I'm going to do is go back into GitHub. I'm going to go back into Actions, and I'm going to run this A/B testing workflow. So give that a refresh, and that's going to kick off. So if I navigate to this now, if I go into revisions, what we should see here once this pipeline has passed, we should see 50% of our traffic being allocated to two different revisions. So right now, this is the revision that's receiving 100% of the traffic. So once this container app has been deployed, we should see a 50-50 split between those two different revisions. While that's running, that might take a little time. So I think let's
Jump to another question.
get some more questions going.
All right. Yeah, lots of good questions. I think we will mention about the VNet being managed by Microsoft. All right, so this question from Shireen. So if you deploy container app with VNet managed by Microsoft, how do you control the traffic and rules?
So you can still control ingress of your container app. So if you deploy a container app environment with VNet that's managed by us, you can still set the ingress rules for that particular container app. And this container app is actually a really good example. So if I go into my bicep file, here I'm not deploying my container app environment. Here that's hasn't got a VNet. I'm not bringing my own custom VNet. So essentially, I'm saying deploy this container app environment, and you can manage the VNet. So the way that we manage traffic to our application is through this ingress block here. So for both of these container apps, I'm accepting external traffic. I've got a target port of 80, and I'm denying insecure traffic to that particular container app. So there are those. So that's how we can control traffic when the VNet is managed by Microsoft. Now, if you have your own custom VNet, you have a little bit more control over the virtual network. As far as I'm aware, inbound IP rules currently aren't available on container apps, but that is coming soon. Again, don't have timelines to share with you all today, but those kind of advanced networking controls, that is a space where the service is getting a little bit better.
Good. Good to know. Yeah, thanks for clarifying. More questions.
Yes, more questions because that's still running.
Yeah, what's the use case where we need to run multi-revision modes for the same app?
Um, Pretty much demonstrating why we need to do that. It's not
Yeah,
necessarily the same application. So if you're making changes to your application, so you might do blue-green deployments to make sure that the version that you're deploying is going to work as expected. So you'll run those integration tests against that container app to ensure that everything's working okay before you promote it to or redirect traffic to it. Again, A/B testing, testing out different features to a subset of customers. So those are just some use cases where multiple revision mode for your container apps is a really a big benefit to how you direct traffic and test your features.
yeah. That question came up when you were presenting just like the slides, but then you got to
Ah,
the codes, it became obvious. One more
awesome.
question. Let's bring. So David Shorter. So are there price implications to single versus multiple revisions?
No, so it's not really on a revision basis. It's more on the resources that you use. So again, it's kind of like a serverless platform. So you're charged for what you use. I think the first like a million requests could be wrong, give or take, are free. Um, but for this example here, so if I go back into my code, I'm running at least one replica at any time. So I'm not scaling to zero on this. You are charged for kind of like idle time on your container apps
Mhm.
for depending on how many replicas you're running. One thing that I didn't mention earlier, so with HTTP and any uh, event-driven based container app, you can scale to zero. But if you're scaling on CPU and memory usage, you can't scale to zero. So you have to have at least one replica running at any time. So depending on how you're scaling, on what you're scaling on, that's also another thing to consider. So to really answer your question, David, there's no pricing implications for revision modes. It's more what you're spending on resources, so replicas in this case.
One more like interesting question from David. Is there like a native integration with a pin for API publishing of different versions?
Yes, so you can integrate container apps with APIN. Um, yeah, that is entirely possible. So there is that native integration, so you can import your container apps into APIM.
Cool. Maybe one more question.
Yes.
What's the
Right.
developer experience like for local dev?
It's a very good question. It's essentially your local dev isn't container apps isn't really concerned with a local dev experience. So your local dev experience really is based off how much very similar to how you would do local development for Docker applications generally. So you'd essentially containerize or Dockerize your application, run it locally in Docker, and that's your local developer environment. So Container Apps isn't really concerned. Container Apps is just a platform to host your containers on. Um, there's no kind of like bridge to Kubernetes, which kind of like brings your cluster into like a local environment. There's nothing like that with Container Apps. Um, yeah, it's just simply I've got a Docker file, I'm running it locally.
Cool. So yeah, no more questions, and I can see the
That's
results on your screen now.
Yes, this is good. So we can see that our GitHub Action flow has passed, and now we've got 50-50 traffic between these two different revisions. So if I go into the container app overview, I've got the URL here, so I don't need to do that. So if I just press enter, I can see I've been allocated to that new revision. Press enter again, allocated to the old revision.
Pretty cool.
Let me scroll in, make it a little bit easier, refresh. So there, because traffic has been allocated 50-50,
Hmm.
we've kind of got a 50-50% chance
Yeah.
on landing on
Right.
different revisions. Yeah.
Yeah.
So that's a very, very basic scenario. So one thing that I do want to share with all of you is this repo here. So
Oh, that's cool.
this is an official Azure sample on front-end A/B testing with Azure Container Apps. This has been developed by Brady Gaister, who again is, I think he's a program manager on the ASP.NET Core team, works a lot with Orleans. Very nice human being. He's kind of led with Pascal here to develop this sample, which is a little bit more sophisticated. It uses beta features, it uses app configuration, bit of feature flag testing, feature flags to kind of switch between different features. So I'd recommend folks check this out.
Can you copy and paste that like on the chat?
Yeah, I'll put it in the private chat so you can
All right. Let me
share it
copy
with the
and paste
folks.
it.
Um, but yeah,
We have one last question.
awesome.
Let's bring it here. So, Shireen, is there like any internal load balancer to manage the traffic in A/B testing?
So there is kind of underneath the hood, there is a load balancer that kind of splits the traffic, that manages that split traffic. As far as you're aware as a developer, um, you manage the traffic through either here on the portal or programmatically using, if I just go back into my testing file, get some real estate going, um, using this AZ CLI command. So that's how we're kind of setting the traffic and testing it.
That's really cool. Well, like lots of questions, and that was really engaging. I think people just felt like it was a really good session and just interested in learning more about container apps.
Yeah,
Yeah,
these are very basic scenarios, and I'm looking to actually tidy up this repo a little bit. But if folks want to have a play around with the code and again see this repository evolve, I'll just share it with you there. But
cool,
essentially,
cool. Yeah,
ACA deployment scenarios. Yeah, this is very much a work in progress repository, but hopefully what I've demonstrated here is how we can actually use revisions and manage our revisions to kind of open up these really cool deployment scenarios, such as blue-green deployments and A/B testing. So I'd really recommend that if you're playing around with container apps, if you're using container apps in Angular in production, use multiple revision mode to your advantage to kind of open up these deployment scenarios for your application.
cool. Thanks, Will. I think like the audience in here is also like thank you just for the great presentation, and I think that's been like a great session. Really, I learned lots. I'm definitely exploring this one and take it further. To be honest, yeah, and thank
Awesome.
you. We really appreciate like your time, and you always like a very keen to help the community. And I hope we have more sessions in the near future. Yeah,
Oh, definitely, man. You know, whenever whenever you can have me, I'm always keen to present and share with the community. Yeah, and if anyone does have any questions, please reach out to me on Twitter. I'm still on Twitter, or LinkedIn as well. I'm Will Velida pretty much everywhere. That's the advantage of having a really strange last name. It's pretty unique. So yeah, any questions, feel free to reach out on social media. More than happy to help.
cool. And thanks for the audience as well. So, well, with here, like we just like end finalizing our session. This is going to be recorded and available on the Coding Night session YouTube channel. And yeah, I think we'll catch up later when we come next.
Awesome. Sounds good.
Cool. Thanks, guys. Thanks, Will. Thank you.
Thanks, everyone. Bye.